OSI model and IP stack. So in this lesson, let's begin. So I've mentioned we're going to talk about the OSI model now, and it's really important. In fact, it's one of those things that once you've done a program like this, it's part of that foundational knowledge that you'll never forget, right? Because you start learning about, hey, it's a layered approach, right? We do things at one layer and they affect the other layer and all that kind of stuff. So what is this all about? Well, it goes back to what I've said, I think a couple times already, that back in the day, early computer systems like this were proprietary, okay? So you bought something from one manufacturer, and a lot of times you even had computer operators from the same company, right? So not only did you buy the computing from them, but you bought the people that ran the computing from the same company. And if you ever wanted software from another company, you didn't have that interoperability like we have now. So we needed some standards models. So there's a lot of different organizations, honestly, that came out and gave us standard options. One of them that's very famous, especially whenever you're learning computers and networking, is the model called the OSI model, the Open Systems Interconnect model. Okay. Now the funny part about this is it's actually developed by a company called the ISO, the International Organization for Standardization. Okay. So, but just remember OSI. Okay. It is a 7-layer model that breaks down network communication. Okay. And basically, we have these layers: physical, which is the lowest layer. Okay, and everything's kind of, if we're looking from, in this case, it would be bottom up. Let me just put this there for now. We're looking at physical. So the physical layer would have all the specifications for the media, the type of cabling or RF, and the type of signaling that is used on the media. Okay, so that's what's defined at that layer. And again, this gives us a layered model so that people can design technology for one layer that's interoperable with the other layers around, surrounding it, right? So physical talks about what to do at the media and signaling layer. Okay, data link layer is where we typically call layer 2, right? And we always label these layer 1 through layer 7 going up. Okay, so layer 7 is up here. All right, so layer 1 physical is the media and signaling. Layer 2 is where we have physical machine addressing. So in our examples, we're using MAC addressing, right? The MAC addresses. And we already looked at that in the last module. Layer 3 is network path selection and logical addressing. So these addresses and most of our discussions are going to be around IP, right? IPv4 and IPv6. Now, there is other layer 2 and layer 3 protocols, honestly, but the kind of the focus in this course, and I will mention some of the others like AppleTalk, NetBEUI, Vanian Binds, right, Sonnet, all that kind of stuff we'll mention, but the focus is really around the 802.3 based Ethernet, 802.11 based Wi-Fi working groups, and on the protocols around IPv4 and IPv6 is the predominant networking protocols in use today, but there's many other protocols out there, right? AppleTalk and all that kind of stuff. So, but anyway, we need a protocol there, and this is the layer that would define that. That would say, hey, for path selection, I need to design a protocol that will help us get from A to B across WANs, across the internet, whatever it is, right? Transport layer is a fun one. That typically comes down to, now that I know how to reach end to end, do I need to send data reliably, or do I want to send data as fast as possible? Okay, so whenever you think of transport and our discussions, the big thing is around, do I need something to be reliable, maybe using TCP, or do I want to send data as fast as possible using UDP? And we'll talk about that. Then we have sessions. Okay, sessions is a fun one, and again, I believe I break all these down into one by one. Yep. Okay. So this is just an overview page, right? We're going to go over all this. The sessions control sessions between applications. So this is how I can have one host address, right? I've got my physical burned-in address that I get from the manufacturer. Then I have another address that's assigned to me logically, okay? And I could statically configure it, or it may be assigned from like DHCP. then that one address may have different network applications running on it, right? So take a server, for example. A server may have a web server service running. It may have an email service running. It may have a SQL service running or database service running. It's all different types of services that may need to be active and talking at the same time. Or from a host perspective on a PC, I might need to be able to have, think about just browsing the internet. I don't know if you're anything like me or not, but I typically have 4 or 5 or 50 tabs open all the time, right? Sessions is what makes that possible. I've got the one address, but I have the ability to have multiple independent sessions going on that same address. Then we have presentation, and that's about how data is represented, okay? And of course, and also if there's any encryption going on. So, and again, this is using the OSI reference model. This is still a very good learning mechanism, okay? And you want to remember these layers. If you take the Cisco CCNA exam, or if you take the Net Plus exam, for example, CompTIA Net Plus, or any of those entry network certifications, guys, they're going to ask you about the OSI model. And you need to understand each layer and what it does here. And we're going to dissect this in detail. But let me give you a hint. People are trying to remember this 7-layer model. 7 different layers, it's a lot. And the application, by the way, is the user application that calls network process, right? So I open up my email client, send an email. That's going to connect to the network to send that email across the network. The application knew that it needed network resources to do that. All right, so we've got this model that we need to remember each layer. There's a couple different ways to do that. One is if you're trying to remember from the bottom up, which means layer 1 through layer 7, okay, please do not take sausage pizzas away. Okay, so let me just kind of write that down for you, and I'm pretty sure I've typed it out somewhere, but please do not take sausage pizza away. So physical data link, network, transport, session, presentation, application. Now that's one way to remember it from the bottom up, but what about the top down? Top down, all people seem to need data processing. I'm not going to write that out, but just know all people seem to need data processing. So these are a couple ways that make it kind of fun and easy to remember these layers, but you still do want to remember application, presentation, session, transport, network, data link, and physical. Everything's easy once you know how. It's just, this is kind of memorization aspect of learning, but it's important because we're going to put these into perspective. Whenever somebody says, hey, that's a layer 1 problem, that's what this model is really used for, and its best use case. It was used to design a few protocols that are out there. I believe it was used to design like IPX and SPX, but it was not used to design like TCP/IP, for example. But it has always been used as a great training mechanism. Okay, so and that we love. All right. So remember your sayings, all people seem to need data processing, or please do not take sausage pizzas away, and that will help you remember the layers. Now let's talk about what happens at each layer. Okay. Physical is about the control of bits. The type of traffic that we send at layer 1 is binary. It really is. It's binary code. It's amazing sometimes that we get from binary code, we get like 4K movies, right? And we get all the Facebook and YouTube and Dropbox and cloud storage and you name it. It all comes back to ones and zeros, man. It really does. I was even thinking about getting another tattoo with the special binary code that's special to me. But I'm getting a little older and it's kind of like, yeah, I got a daughter. I'm probably going to get another tattoo. Anyway, so the physical medium is about bits. Okay, that's what we transmit at layer 1. The data link layer is frames. So those bits turned into a culmination of bits which has encapsulated data in it. Okay, and then those Frames are then used to become packets, and then we have segments and all that kind of stuff. So before we get into that though, just make sure you understand the layers and the numbers that go with them. So I should know layer 7's application, layer 6 presentation, layer 5 session, layer 4 is transport, and this is for the OSI model. Now there's two network reference models we're going to be discussing in detail, but this is the OSI, and it's definitely very important, okay? So let's talk about some more of each of these. So application provides services directly to user applications, can also establish privacy mechanisms, authentication and communication, and determining if adequate resources are present. Then there's the presentation, how we are formatting the data that is shown to you. And also compression and encryption can be used at layer 6. Layer 7 is about the sessions between different endpoints, even though I have that one address. I've already kind of talked about that one a lot. Transport insulates the upper layers, 5 through 7, from dealing with complexity from lower layers as providing functions to guarantee reliable network, right? We also have mechanisms for error recovery, and we do segments at that layer. So basically, if we need to have reliable data transmission, let's say I'm backing up a database. If I start sending that across a network and we have a bunch of dropped packets, that could corrupt the database. We don't want that. So for that transmission, we need to make sure we use a reliable network protocol. And we have that option. In fact, we have that option on a per session basis to send data reliably or just best effort. It comes back to really those two things. Reliable data transmission or best effort. And transport is the layer where that's dealt with, okay? Those are your options, all right? So let's keep exploring this a little bit, and there we go. Remembering the 7 layers. Please do not take sausage pieces away, or all people seem to need data processing. So quick question, now that you're learning this, which one is top down, the other one, and which one is bottom up? All right, do you remember already? If you were saying that the first one is bottom up, you'd be correct. And if you were saying that the second one was top down, you'd be correct. Because it's a 50-50 chance, right? So good chance you got that one. Now, how does data flow through these layers, right? Because we have all these different mechanisms. They all have to work together. What binds this, right? That's a great question. Each layer allows me to have, I start off with data. Let's say I send you an email that says hello, okay? Well, I did put in also your email address that says your name at a domain, okay? And so it's addressed to you, and it's got a, what do you call the freaking lines? The top line in the freaking email? The title or whatever. Subject line, jeez. Losing my mind there for a second. So we've got the subject line to say what it's about. Then we've got the message body that has the details, okay? Well, that message body and everything is data. Okay, so that's the data I'm going to send you. And let's just say I said, hi, what are you doing? Or something like that. So hi, that's data. But we need to now, that data needs to be passed down through the stack so we can get it across the wire to you. Okay, so we're going to encapsulate that data. And we're going to add headers. And by encapsulating and adding each header at each layer, we know the way to build that packet to be sent across the wire, okay? So we might say we want the data being transmitted in this format, and we need this compression, whatever it is, and we add that encapsulation, that header from presentation layer. Say, yeah, we're going to encapsulate. Then we say we need a new session. So we add a header for that session and saying, hey, yeah, we need a new session. This is going to be sent out a new way, and or we need to access, this particular service, whatever it is. Then we go to transport. Okay, transport's going to say, does this need to be a reliable connection with the destination, or can it be just sent as fast as possible? Well, since it's an email, we probably want to send data reliably. We don't want somebody to get a portion of that message. So we can say, hey, we need a reliable connection for this, right? And because we were sending an email back in session, we would have said, hey, we're going to use port number 25 for SMTP to be able to send that across the network, right? So that was encapsulated. Then we got the transport saying we're going to use reliable connection. Now we need to figure out how to freaking get there. So where is this mail server that I'm sending this email to? Because it doesn't just go straight to a person. I type the email, I hit send, which goes to a mail server. The mail server then routes that message to the next domain. And then once that mail server on their side gets it at that domain, it drops it in the user mailbox that you put ahead of the domain. So whenever you email like Chris at Wi-Fi Training, for example, man, my penmanship with the tablet where it's at is horrible. I will change that moving forward. Well, whenever you send that email, a lot of things are going on in the back end. That's the great thing is once you kind of understand how this stuff works on the back end, you're like, man, technology is really freaking cool to give me the user experience that I have today. But in short, I was using an email application. That email application, whenever I hit send, is going to connect to my server from whatever domain you're on, right? So it's going to connect to your server, and it's going to give the email message to that server. Then that server is going to finish the routing to the remote server, which would be at the wifitraining.com domain. And once that message arrives, then it'll be distributed to my username at that mail server, right? If I exist and all that kind of jazz. Now, so this first part of the message transmission, the network, what I really need to do is figure out who my mail server is, right? So a couple things are going to have to happen here. One is I'm going to have to find out the host address. So, and we're jumping a little ahead again. I apologize in advance, but we know that we're going to send, let's say my mail server name here is mail.demo.local. Okay, that's the example I'm using. So I have to resolve that. Obviously, hopefully there's going to be a mail server running at that address, but we don't really use names to find things. Names get mapped back to IP addresses. Okay, so, and that happens through a process called DNS. So we do a DNS lookup to find the IP address of mail.demo.local. Again, I'm jumping ahead. I apologize. I promise you it will all come together. Once I have that address, then I know my destination address, right? It's going to be whatever mail.demo.local is. That's my destination address. My source address, and remember, I'm sending this to my mail server. My source address is my local IP address. Okay. Oh, there's Hannah. So once I know the IP address for mail.demo.local, I have my destination address. My source address is my local IP address because I'm sending my local mail server. So I'm going to put that header on there that says here's my source and here's my destination. Okay. And then I've got a whole other encapsulation process to go through at layer 2. That's to get me from A to B kind of thing. Right? Finally, once that packet is built and it's ready to go, then I convert that to ones and zeros. Send it across the wire. Whenever that destination box gets it, they're going to de-encapsulate the process. So we have this whole process here of encapsulating at each layer and then de-encapsulation. So whenever I'm sending this across the wire, it's sent as ones and zeros. You see there's a lot of headers on here, right? And the remote destination starts stripping them off. He gets the packet, he starts stripping them off, right? Where does this need to go at layer 2? Where does it need to go at layer 3? What transport are we using? What session are we using? Presentation, and so on. And that's how communication takes place using the OSI reference model. Now, remember I said the OSI reference model is one of a couple models that we're going to be talking about. And it's very useful for training, and you definitely want to know all of this, okay? But we have some other models too that we need to understand. Now, on this OSI model, these are the lower 4 layers. what type of traffic is sent at each layer. You remember what I said? So layer 1's bits. Whoops. I thought I had this in a nice little animation, but I'll write it out. So layer 1, we send bits across the wire. Okay. Layer 2, the type of transmission that happens there is frames. Layer 3, the type of transmission that happens there is packets. And layer 4, the type of transmission that happens there is segments. So that's some more terminology to go with the type of transmission that's done at each of these layers, right? All in all, everything comes across the wire's bits. But then whenever I start de-encapsulating or re-encapsulating and then de-encapsulating, figure out what's in it, I've got frames. And then the frame is going to have the data in it. Whenever I get to the destination host, he's going to look at the packet and say, okay, what's in there? And so on and so forth. So that's encapsulation and de-encapsulation and the type of transmissions at each layer. All right, now remember I said there's a couple different reference models out there. OSI, yes, is definitely one of them, okay? But the predominant in-use model that we use every day of our lives, okay, is IPv4. So here's what you need to know about IPv4. First of all, that we're going to be talking extensively about it throughout the class from now on, basically. It does rule the world whenever it comes to networking, and its bigger brother and much bigger brother IPv6 are the two most predominant by some astounding number network protocol out in the world today, by far. Okay, so the OSI reference model was used as a training model, and it was used to develop some protocols, but there's not many that are still around today. Maybe ISIS or something like that, or X400. Most of the protocols that were kind of based off that reference model are just no longer around. So we needed a command and control network that could survive a nuclear blast. And I'm not even joking about that. DARPA, the Defense Area Research Agency project, is the one who developed TCP/IP and IPv4. They did it so that we could take a nuclear blast to the command and control network that controls our missile defenses and everything, and still be operational at all the other locations. That we needed a type of network like that. So IPv4 was born there. Okay, and then it was very humble beginnings. Okay, so we released it in the wild, and other agencies and people and companies and really just a lot of like hobbyists at first connected to it to share information. Medical professionals could share information, and you had this guy named Tim, right, who started developing a language that could be used to display content and multimedia in this kind of new fashion called HTML. And that gave us the world we have today, basically. I mean, our entire universe. My daughter's 4.5 years old. She could teach you to use an iPad. And a lot of that was spawned and based off of this innovation called IPv4, because businesses wouldn't be where they are today without the ability to connect and share information the way we've been able to, thanks to these protocols. All right, so here's what you need to know about this. For both the Cisco certification and the CompTIA certification, the link layer combines layers 2 and 1. Okay, internet layer and IPv4 is mapped to the network layer. I've seen both of those exams ask questions like, well, which is layer 2? And they call it internet or network. Well, if they're asking about the OSI model, they're asking about, at layer, what they're going to try to do is say, what's the layer 3 protocol for the OSI model? And they'll give you the option of internet, right? And that wouldn't be correct, because that's layer 2 of the IPv4 stack. And again, these are two different models. It's just that IPv4 won over for so many reasons. Okay, a couple of the original kind of reference protocols are around. IPX and ISIS is the ones I could think of off the top of my head. There's a lot that aren't around anymore, right? From that OSI reference model, but it gave us a training reference model. It gave us all people seem to need data processing, and please do not take sausage pieces away. That's what you got to know. I'm just kidding. You do need to know the other stuff. So remember, like whenever somebody says, hey, what type of stuff happens at the application layer? Well, that's where we decide on which network application to use. So are we going to use DNS? Are we going to use HTTPS? Are we going to use FTP, SIP, SSH, whatever that is? We decide all that based on the application calling on those resources. Well, what about presentation layer? Well, are we sending pictures? Are we sending text? Is it a JPEG and MPEG? What is it? Session layer. Well, do we need an NFS session? Do we need a NetBIOS session, for example? That's what happens there. Transport layer. Do we need a reliable session or unreliable session, right? Are we sending data reliably or via best effort? Okay. Network layer. We've got an IP address, right? Or if you're using the OSI network layer, then we could be using, IPX. We could be using other stuff. Layer 2, that's where, ARP and ATM and all that stuff lives, depending on what we're talking about. Frame relay, HDLC, MPLS. So again, it also depends on there's different protocols that are used depending on the type of device you are, right? And we'll talk more about that as we go forward. And then the physical layer, again, are we using, Wi-Fi, 802.11? Are we using DSL? Are we using Ethernet? Are we using Bluetooth? So all of those things you should know about these layers and how they interact with each other for the OSI model. And then we need to know that they are combined in the IP stack. That these lower two layers will basically look, do we have a link? Is it active? All right, we're going to send data. We need a network address. Okay, so we're going to have to do something with that. And then the other thing is that do we need a reliable session or not? So the IP stack is much simpler in a way, right? Because I use this application and we decided we need a certain protocol. In fact, I've got an example, I think, pulled up for you here. Let's go down here and see our example. So here's our example. IPv4 stack, right? So we've got this user data. We're going to convert for transmission. It's this type of data, blah, 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 blah. The application handles all that. As a network engineer, this is cool because we're like, hey, that's upper layer stuff. So that's user data. That's going to be put into a packet. And I care about how packets get from A to B and how frames get from A to B. Right? That's your job as a network engineer. That upper layer stuff, that's the developer's kind of role, right? So that data gets the correct conversion, the correct format, and we're going to put on a header. And that header, let's say that we're sending, that email. So we're sending an email. We're going to use TCP for that session. Okay, so we're going to put it on TCP header. Then we need to decide how to get to our mail server. So I'm going to put on my source IP. And I'm going to put on that destination IP. And of course, we'd still have the TCP header and the user data. Then the link layer is going to convert that to ones and zeros, send it across the wire, and then we de-encapsulate the process. So the encapsulation process happens as we create and send data. The de-encapsulation process happens as we receive data and need to understand the data. All right. So and nowadays, guys, IPv4, I mentioned DARPA created it, but DARPA isn't probably the best agency to, don't get me wrong, these guys are brilliant. Some of the most kind of coolest tech has come out of DARPA, even though it was originally for military and still is for military purposes. They've done a lot of really cool innovation over the years, and it's fun to look into. So if you get some free time, look at DARPA and DARPA innovations. It's cool stuff. But IPv4 and IPv6, guys, is now managed, of course, by another agency, and I'll go ahead and bring them up. That's the IETF, the Internet Engineering Task Force. Okay, so they are responsible for protocols and standards that are around the functionality of the internet. So this is where you'll see like the RFC, request for comments, right, standards. You'll see like RFC 1918 and stuff like that. There's hundreds and thousands actually. But they're responsible for the protocols and services for the functionality of the internet. And that agency is who manages the whole IP protocol suites nowadays. All right, hope this has been informative, and we'll see you in the next lesson.